Well, we discussed a moment ago permutations. This is where we've got objects to place in a sample space where order is important. That's what makes a permutation. The order is important. But what about when we've got more objects than we have sample space? And if order is still important, it's still a permutation. But we have to then rely on a permutation formula. So we're going to present this two ways. One is we could then say, as far as our formula, that n factorial over n minus r factorial, where n are the number of objects and r, let me make a little bit better r here, r are the number of spaces. Now another way, and we're going to see this on that we can represent this, and we're going to see this on their calculator, and I guess I'll show it in two different ways. We could say n p r, where that p, n still represents the number of objects, r still represents the number of spaces, but p is telling us it's a permutation. Or you may see it like this, n comma r. And depending on the way your version of your TI-80 or Texas Instruments calculator, you may need to use one of these two, which we're going to look at in a moment. But first, let's address this particular problem. James wants to place 5 of his 8 trophies on the fireplace. How many ways can he arrange the trophies? Well, order is important in that once I use one of those trophies, I can't duplicate it. It's only going to be used one time. It can't occupy 2 of the 5 spaces. So then we can say then that 8 factorial over 8 being the number of objects, 8 minus 5 factorial, and then let's see, that could equal 8 factorial over 8 minus 5 is 3 factorial. And if I were to simplify that again, let's see, what's 8 factorial? 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 3 factorial, which is 3 times 2 times 1. And then you can see that these cancel, and I'm left with 8 times 7 times 6 times 5 times 4. Now, I'm going to move over here to the calculator, and we are going to perform this permutation, one using factorial, one using our permutation feature or function on our calculator, and hopefully they're going to end up being the same. If not, we're in trouble. All right, well, first let's do this. We'll just do it as a factorial. But this is really not the way I would do a permutation. So if you recall, we had 8 factorial over 3 factorial. So I go to math. I go to probability. Wait a minute, I need to clear. I need to put the 8 in first. All right, 8. Glad I thought about that. Now math, go to probability. I'm going to choose option 4. And Shazam, that is 8 factorial. And we're going to divide that by 3. Going back to the probability feature. Choose option 4 again. 3 factorial. And let's hit enter and see what happens. Well, that's 6,720. He's got 6,720 different ways he can place those 5 where order is important. Place those 5 out of his 8 trophies on his fireplace. Wow. Okay, now let me show you how I really would do this. I'm going back to the math, and I'm going right here to probability. But this time, if you look, option 2 is n permutation r. And I'm just going to choose option 2. And I'm going to fill in the blocks. 5 Whoop, that's not true. 8, 5. We got 8 objects. We got 5 spaces. We're saying that order is important. Let's hit enter. And Shazam, it's the same answer, 6,720. So I got a permutation. Order's important. I got 8 trophies. That's 8 P. I got 5 spaces to put them in. 5. Hit enter. 6,720. Now we're going to look at combinations. A little bit different because in a combination, order is not important.